Why waste time in commute and spend lot of money for IITJEE coaching? Parents, do you want your kids to achieve top scores in IITJEE? India's leading online NEET coaching 100% success IITJEE. At TeenEinstein, we focus on IITJEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com.
So far we have talked about the basic properties of an electric charge. Now what happens when you bring one charge near another charge? It is going to exert a force between each other. So we already talked about this force, that like charges repel each other and unlike charges attract each other. So how do we quantify this force? So what is the magnitude of this force? So all this information is given by Coulomb's law. So basically Coulomb's law gives us information about force between two point charges. So an important thing to note here is, when do we consider the charges to be point charges? We can assume charges to be point charges if the distance between them is very large compared to the size or the dimension of the object itself. So when two charges are separated by a large distance and the distance is very small compared to the size of the object, we can consider that object as a point charge. So Coulomb's law gives us information about the force between two charges. So it tells us that the force between two point charges varied inversely as the square of the distance between them. So when Coulomb conducted the experiments and came to the suggestion, he suggested that the force between two point charges have to be varying inversely proportional to the square of the distance between them. And also, what about the magnitude of the charges? So if you have a bigger charge and if you have a smaller charge, there will obviously be differences in the forces between them. So the force between two point charges also was directly proportional to the product of the magnitude of the two charges. Okay, so now we have an idea about the magnitude of the force. So we know that if the distance is increasing, the force will be decreasing as the square of the distance. And if the charges are increasing, then the force will be increasing as the product of the charges, because the force is directly proportional to the product of the charges and the force is inversely proportional to the square of the distance between them. What about the direction? So we know that force is a vector quantity, so it has to have a direction. So the direction of the force between two charges will always be along the line joining the two charges, and whether it is towards the right or towards the left, the direction will be decided by the magnitude of the charges again, or whether the charges are positive or negative. So Coulomb law can be expressed in this expression: F is directly proportional to the product of Q1 Q2 divided by R squared, and instead of using proportionality constant, we add a constant called K. Okay, so now this is Coulomb's law, F equal to K Q1 Q2 by R squared. Now, okay, this is a charge Q1, this is a charge Q2, the separation is R. So we have just given the two point charges separated by R. The force between them is given by this. Now, if we remove this magnitude sign, how this equation takes care of the polarity of the charges? For example, we know that if both the charges are positive, let's say this is a positive charge, this is also a positive charge, and the distance is still R. Now what will happen to the force? So the force here, what I have written, is F21, that is the force exerted on 2 by the charge 1, and that is going to be towards the right, because both the charges are positive. So F equal to K Q1 Q2 by R squared will give me a positive charge. So conventionally it has to be towards the right hand side. What if one charge is positive and this charge is negative? Again we'll look at the force F21, that is the force exerted on Q2 by Q1, that force now will be along the left side, because now Q1 is positive and Q2 is negative. So overall F will be minus. So F will have a minus sign, so it will point towards the left side. So this is how this equation, if you remove this modulus sign, it will take care of the signs. And conventionally we know that like charges repel each other, so this has to move away from the positive charge, and unlike charges attract each other, so this negative charge has to move towards this positive charge. So this is Coulomb's law. Now Coulomb's law can also be applied vectorically like this. So first, before going into that, we will see what is this constant. We saw that F equal to K into Q1 Q2 by R squared. So now what is this K? So this K can be expressed as 1 by 4 pi epsilon naught. So this is the proportionality constant from Coulomb's law. So what is this epsilon naught? Epsilon naught is called the permittivity of free space, and the value of epsilon naught is given by this. So epsilon naught is not always this way, because when you use a free space, then this is epsilon naught. When you use another material, this value will be different for that. So overall, this is Coulomb's law. This is the force between any two charges separated by a distance. But there is something missing here. It only gives the magnitude of the force. This formula gives only the magnitude of the force. So what about the direction? So in order to understand the direction, we need to go to vector picture. So let's take charges Q1 and Q2 here, and this is origin. R1 is the distance of charge Q1 from the origin. R2 is the distance of charge Q2 from the origin. So R1 and R2 are vectors here. And now this F12 is the force acting on Q1 due to Q2. And F21 is the force acting on the charge Q2 because of the charge Q1. So this is along this direction, this is along this direction. We will see how it comes. And before that, what is R21? R21 is nothing but R2 minus R1. So it is nothing but the distance between the charges. So now here R21 is along this direction, and this is a unit vector. So the force here F21 and so what happens if Q1 and Q2, the product of Q1 and Q2 is greater than 0? So when we say greater than 0, it has to be positive. What are the chances of the product Q1 and Q2 to be positive? They have to be like charges. They either have to be both positive, or they both have to be negative. So if they both are positive and they both are negative also, we get greater than 0. So what happens in this case, when they both are positive or when they both are negative, the charges have to repel each other. So the force is F21 is along this direction, and the force is F12 is in the opposite direction, and this is given clearly here. So when F21 is in this direction, F12 will be in the opposite direction. Similarly, because the product Q1 Q2 is greater than 0. But when the product Q1 Q2 is less than 0, that means either one of the charges is positive and other charges is negative. So this is unlike charges. So unlike charges attract each other. So when they attract each other, the force also points towards each other. So overall, if you want to express the force between the charges according to Coulomb's law, you have to include this unit vector R21 here. So when you include this unit vector, this becomes a vector quantity. So this is Coulomb's law. Okay. So far we talked about what happens to two charges. Now what if there are more than two charges? So we are going to use a principle called principle of superposition. So how do we use this? Force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges taken one at a time. These individual forces are not affected by the presence of other charges. So this principle is called principle of superposition. So what do we do here? What does this say? Let's take just one force, Q1. So in this configuration, there are three forces. So we are going to take the charge Q1 and find out what is the force on this Q1 due to the charge Q2 and the force on this Q1 due to the charge Q3 individually ignoring the effect of other charges. For example, first I need to find out, so the aim is to find the total force acting on the charge Q1 due to these two charges. So first what I do, I ignore the charge Q3 and continue to do this only with the charge Q2 and find out what is the force exerted on Q1 due to Q2. So that is nothing but F12. And again I'll do the same thing with Q3 this time. I ignore this Q2 and I take this charge Q3. So I find the force between Q1 and Q3 and that is F13. Now this is a vector, since it is in this direction, this is in this direction. If I find the vector sum of this forces F13 and F12, that will give me F1. So this F1 is the overall force that the charge Q1 is experiencing because of these two charges. So what we did is we first took charges one by one and found out what is the force, and we took the vector sum of the force. So similarly, what if we have more than 3 charges? Here we have only 3 charges. In this case, we have like 5 charges, Q1, Q2, Q3, Q4, Q5. Now our aim is to find out what is the final force on Q1. So first what we will do, we will just take Q3 and find out what is the force on Q1, that is F31, and take Q5 and ignore all the other charges, take what is the force, that is F51, and again similarly ignore all the other charges and take Q4 and find out what is the force, that is F41, this is the vector, and again ignore all the other forces and take Q2 and find out what is the force, it is F21. Now what we have to do is we have to find the vector sum of all the forces, F21, F31, F41, F51. So first let's take F21 and F31, and that where the sum of this F21 and F31 is here in this vector. And again we are taking the sum of F41 and the sum of F21 and F31, and that is this vector. And finally that resultant vector taken with F51 gives us this. So this F1 is nothing but the vector sum of F21, F31, F41 and F51. So this is basically superposition principle. Basically what it tells you is, if you have so many charge configuration, you want to find what is the total force on one charge, just take one by one and add all the forces in a vectorical way. So this will give you overall force acting on it. So the example which we saw here is F12. So how do we find out the force F12? By using Coulomb's law. We know 1 by 4 pi epsilon naught into Q1 Q2 by R12 square, and R12 cap is the unit vector joining the two charges. So F12 is given like this, and now what we have to find is F13. What is F13? It will be 1 by 4 pi epsilon naught into Q1 Q3 divided by R13 square into R13 cap. Now the vector sum of these two forces will give us F1. So in a general case, if you have a lot of charges, n number of charges, what you have to do, this F1, what is F1? F1 is the force on charge 1 due to all the other charges. So we have F12, F13 up to F1n. So this will be 1 by 4 pi epsilon naught is common, so we are taking it outside. So each product will have the pair of charges Q1 Q2 by R12 square R12 cap plus Q1 Q3 by R13 square R13 cap plus up to Q1 Qn by R1 squared R1n squared into R1n cap. Thank you.
Why waste time in commute and spend a lot of money for IITJEE coaching? Parents, do you want your kids to achieve top scores in IITJEE? India's leading online NEET coaching 100% success IITJEE. At TeenEinstein, we focus on IITJEE coaching from Class 6 to Class 12. We think you'll like it. Our teachers are mostly PhDs in physics, maths, chemistry, botany, and zoology, with lots of years of teaching experience for Class 6 to Class 12. Thousands of videos, quiz, MCQs. We provide a daily worksheet of 30 questions on each topic: math, physics, chemistry, and biology, for rigorous practice, concept understanding, evaluation, quiz, and thousands of videos. Limited offer 40,000 rupees per year. Book your class. TeenEinstein.com